There we go. So how do we report our results? So graphs are so important. You are going to find that even though you guys are online, I expect quality graphs, okay? So as you're doing your quality graphs, number one, you are not allowed to do computer graphs. They have to be handwritten. And I'm sorry, but you know what? To do a graph handwritten is to understand what a graph means. Does that make sense? Versus a computer spitting it out for you. Okay, so here's what you're going to do. You have collected some data. I don't have the data table, but what you've collected is when you look at your data tables, you will see the molarity next to the absorbance, right? So a 0 molar solution has an absorbance of 0, meaning it doesn't absorb any light. Am I right? A 0.1 molar solution has a little bit of absorbance. And as you got more molarity, you had more absorbance. So what we're going to show you is how to go ahead and report that in a graph. And so what you're going to do is you're going to plot the known things. Remember, you had to do 3 unknowns, and you're like, what's that about? I'm about to tell you. But you had a whole list of known molarities. You know what those molarities are because you took a lot of time to actually make those molarities. You made a 0.1 molar solution, a 0.2 molar solution, a 0.3 molar solution. Am I right? So those are known values. So you go ahead and plot those. First thing is, you have to go ahead and put your independent variable on the x-axis. So the x-axis. This is how I tried to explain it. I don't know if it was in your discussion board or somebody else's, but I think about the independent variable is what you independently chose to manipulate. You chose to change the molarities. Well, I told you to, but it could have been something you came up with on your own. You independently chose. So it was ever the manipulated value was, okay? The result of that depended on which one. So the results up here on the y-axis, this is where the dependent variables go. Alrighty, so here is your independent variable with all of your known, with all of, your molarities that we did. It needs a label. All axes need labels. So this would be molarity concentration. I'm hand giving you this. Molarity concentration of CuSO4 5H2O. I'm breathing in these markers. Jeez. Ooh, look at that. Long label. That's right. This is absorbance. So when it was 0, it was 0. Feel free to plot that. When it was 0.1, well, I need to make it better than that, don't I? And by the way, you might not have a 2. You need to set your scale according to your data, okay? So sometimes I have people with data that's a lot bigger. It really depends on our equipment, I'll just be honest with you. So what I choose to do is look at your top number of data and go slightly above that in something that's going to give you good increments, okay? I chose to make it 2.00. Well, this is not good enough. So I'm going to go ahead and cut this in half, 0.50, and then it's 1.500. I'm going to go ahead and cut those in half. Boom, 0.250. And you should not have the exact thing I have because none of you guys went up to 2. I noticed nobody went up to 2, so this is not your scale. I'm giving you an example, okay, of how to put together a proper scale. This is a great tool in trying to figure out what your scale is. 7.5. Does that look right? When I go fast, no. When I go fast, I tend to make mistakes. How's that look? Is that better? Looks good to me. Alrighty, so I'm just making up some numbers. I'm thinking, remember I didn't do the data myself. When it was 0.1 molarity, I'm thinking you came somewhere around here. 0.2, somewhere around here. 0.3, I'm just plotting what I think it might be. Okay, 0.5. There was no 0.6, but I needed to keep my scale according to the boxes, right? I need to keep it in increments that are equal increments. I couldn't just throw a 7.5 there just because that was the next number. So right here, 0.75. I'm going to go ahead and throw that right there. Okay? And then you got 1. 1, I'm going to throw it up there. Alrighty, so what I did is I just plotted known data. Let's put that on the key. Black, known, molarity, concentration, C-O-N-C, concentrations. Oh, I forgot a label over here. Now that we got these numbers, absorbance. A-B, absorbance, and put the nanometers on it. It was at 635 nanometers. I'm giving you all kinds of good stuff, okay? Alrighty. Now, I don't have a ruler in here. I know I need a meter stick is what I need. Meter stick. What you do is you take your ruler, you put it smack dab in the middle of the data, okay? I'm going to choose just a different color. I had meter sticks in my other lab thing, and I just didn't bring one in. So you're going to go ahead and put it in the middle of the data lines. We're not playing connect the dots, okay? So that was to illustrate that I'm putting it in the middle. Woo-hoo! See, it does not connect the dots, and that's terrible. That's why I use a ruler, okay? Made a standard curve is what I did. So I used known data points that I got the data for to establish a standard curve. You could even put that on here. STD curve. And what the standard curve is, this is a tool that can be used to predict other values. So we had 3 unknowns, right? Yeah, we had 3 unknowns. So I'll go ahead and grab another color. I only had the 3 colors, sorry. But it's okay, we shouldn't be color dependent anyway. If you, for some reason, cannot distinguish between the colors, you don't have to put that out there to the class. You can just let me know, okay? And then we can work on X's or something. If you can distinguish the color, I would prefer that you use color, okay? But that's personal between you and I. Alrighty, so I'm going to pretend that I did unknown B. Just made it up. And unknown B, I don't know what the molarity is. Yeah, I know you saw it on the bottle, but I don't know why it's on the bottle. It's not supposed to be on the bottle. But you got an absorbance for unknown B. I don't know what it was. I'm going to make it up. I'm going to pretend like the absorbance for unknown B was somewhere over here. Right? So what you do is you use your ruler, take it across to your standard curve, take it down, and you can guesstimate unknown B is about 0.75. So to repeat, we have used known data to establish a standard curve. That way we can guesstimate unknown data. And you'll do that for all 3 of your unknowns. Plot them on there. All right, that's it. Oh, that's not it. I saw you shake your head, so I was like, yeah, we're it. What is my graph missing? Title. Exactly. Because it means nothing without a title. So I'm going to teach you how to make a great title. In grad school, I had so many graphs sent back to me. And those graphs being sent back to me because I just had like a little title. And by the way, this is not business. This is not humanities. I don't want cutesy titles. I want descriptive titles telling me what you're looking at. Sorry, I shouldn't bang. It's probably banging in the mic. So what that means is, here's the key to making a title. Take what's here on the independent variable. Take what's here on the dependent variable. Keep in mind what's going in here in your key. Throw it all together and put it in a title. I've had titles that are like sentence beyond sentence long, okay? And they're like wonderful. So, known molarity concentrations of copper sulfate pentahydrate used to determine, let me start over. Absorbances of known molarities of copper sulfate pentahydrate used to establish a standard curve to predict unknown values of copper sulfate pentahydrate. Boom. I just took that, threw it in the title. Yeah, welcome to science. All right.